A completed chemistry assignment can feel like proof learning happened. The questions have answers, the work is turned in, the grade book shows full credit. Everyone can finally move on. Yay! But a finished worksheet proves only that the worksheet was finished. It doesn't always prove that the student can retrieve the ideas later, recognize when to use them, and or solve a problem independently. Even when they did the work all themselves, they may have just followed the pattern from the example directly above the question. They may have used their notes for every step. They may have recognized what they were looking at without having to recall it. They may have repeated the same type of problem 10 times in exactly the same order. While they were doing that, the chemistry can feel completely familiar. And familiarity feels a lot like knowing. The student sees the formula and thinks, yeah, I know that. They look at the worked solution and think, that makes perfect sense. Totally have this. They reread their notes and think, I remember learning this. Yeah, I got this stuff. It's great. But recognizing something when it is in front of you is different from retrieving it when the page is blank. That difference becomes painfully visible on test day. The notes are closed, the example's gone, the problems may appear in a different order. The wording may change. Several different problem types may be mixed together. Now the student has to decide, what kind of problem is this? What information is it that really matters here? Which relationship should I use? What is the first step? And how can I tell whether my answer even makes sense? That is a much stronger test of learning than whether last night's homework was completed. Chemistry makes this especially important because students can memorize the appearance of a solution without understanding the reasoning underneath it. For example, a student may learn that a certain worksheet requires dimensional analysis. They follow the example, place the numbers into the conversion factors, and complete the page successfully. But if the next problem is written differently, can they still determine which units cancel? Can they explain why the conversion factor is arranged in that direction? Can they build the setup without copying the pattern? Or consider stoichiometry. A student may complete 10 problems while the chapter heading tells them exactly what kind of calculation to perform. But on the exam, the problem won't announce, this is a grams to moles, moles to grams problem. The student has to recognize the relationship themselves. That recognition is part of learning. So how can a parent tell whether the chemistry is actually sticking? You don't need to become the chemistry teacher. You can use a few simple checks. First, close the notes. Ask the student to explain the idea on their own. Not repeat the textbook definition. Explain what it means to them. Second, change something. Use different numbers. Change the wording. Mix the problem with a different type of question. Ask what clue tells them which method to use. Third, wait. Just wait. The student may be able to repeat the process immediately after seeing it, but can they still do it tomorrow? Can they begin after a weekend without relearning the entire method? Fourth, ask them to predict before calculating. What kind of answer should they expect? Should it be larger or smaller? Positive or negative? More acidic? More basic? Will the equilibrium shift to the left or the right? Prediction forces the student to think about meaning, not only procedure. Fifth, ask them to find and explain a mistake. Students often believe that learning means getting the answer right immediately the first time. But being able to inspect their work, identify where the reasoning changed direction, and correct is strong evidence of understanding. These checks reveal something that completion grade may not show. Can the student retrieve? Can they choose? Can they explain? Can they apply? And can they correct? That is learning. This doesn't mean every homework session needs to become another exam. Students need space to learn with notes, examples, hints, and support. The first time they encounter a new idea using those supports is completely reasonable. But the support should eventually be removed, long enough at least to find out what remains. A helpful sequence might look like this. First, learn the idea with an example. Next, solve a similar problem with some support. Then, close the notes and solve one independently. Later, return to the idea after time has passed. Finally, mix it with another problem type so the student has to decide what to use. That last step is important. In real chemistry, the student is rarely told which chapter the problem came from. They have to recognize the structure underneath the words. This can be particularly challenging for students with ADHD because familiar materials can create a comforting sense that the work is understood. But retrieving information, choosing among possibilities, and organizing a response without prompts requires a different level of mental effort. That's why a student may honestly believe that they are prepared and still feel blindsided during the test. They weren't lying about studying. They confused familiarity with availability. The information looked familiar when it was in front of them, but it wasn't yet available when they needed to produce it alone. So, after the homework is complete, don't only ask, "Did you finish?" Try asking, "Can you explain one problem without looking at your notes? Can you solve a similar problem if I change the numbers? What clue tells you which equation to use? Could you still do this tomorrow?" What mistake would most students make here? You don't need to ask all 5 questions. One well chosen question can tell you much more than another hour spent staring at a completed work. The goal is not perfect worksheet. The goal is knowledge that the student can access when the worksheet is gone. Because chemistry is not mastered when the answers are on the page, it's mastered when the student can produce the reasoning independently. In the next lesson, we'll look at why traditional chemistry tutors can provide excellent explanations and still fail to address the student's deeper problems with starting, organizing, and working independently. Before you move on, choose one chemistry topic your student recently finished. Ask yourself whether they could retrieve and use it without looking, or whether it only seemed familiar with the notes open. Share what you noticed below or write it down privately. Thanks. Have a blessed day.